students, in last video we studied about the definition of electrostatic potential energy and the expression for electrostatic work done against the electrostatic potential energy. Then this equation is du is equal to f bar into dr bar. Then in this video we studied the expression for potential energy. In this then the source charge source charge plus q0 q is situated at point O, and because of this source charge q0 the electric field around them. Consider the another charge q0 which is situated at point A from the at a distance of r2 from point O. Then this q0 charge is displaced from A to B, and this B point which is lies from a distance of r1 from the point O. If the force is act on them, then the charge is displaced from point A to B. Then work done against the electrostatic force. Then the work done against the electrostatic force means Fe, and because of this force there is a displacement, then increase in potential energy. Increase in potential energy, the force act on them means electrostatic force act on them into dr bar. This is the first equation. Then due to the displacement of the charge from initial position A to the final position B, then the increase in potential energy means delta U, which is equal to means there is a displacement from point r1 to r2, means integration. Here we take integration from r1 to r2, then r1 to r2 increase in potential energy du, which is substitute the value of du in place of this, then r1 to r2 into Fe is equal to Fe bar into dr bar. This is the equation second. Then according to Coulomb's law, we know that the electrostatic force between the points between the two charges q and q0, then the electrostatic force Fe is equal to the 1 upon 4 pi epsilon 0. Here is the minus sign, then two charges q0, and these two charges are separated by distance r square and into r cap. Here r cap means unit vector which is direction in the direction of r bar. Then here we calculate the increase in potential energy, which is denoted as delta U, which is then integration of r1 to r2, means displacement is from r1 to r2. Then here the value of Fe, then substitute the value of Fe in this equation, 1 upon minus 1 upon 4 pi epsilon 0 into q0 upon r square into r cap. Then in this equation next is dr bar. We know that the displacement and force are in opposite direction, so negative sign is there. Then total electric field for system of two charges, the potential energy which is directed from r1 to r2, but we know that minus 1 upon 4 pi epsilon 0, which is the constant term, and the q and q0 which is also constant, only the change in that, only the distance displacement is change. So this displacement is from r1 to r2, numerator is r cap upon r square into dr bar. Means here if 1 upon 4 pi epsilon 0 q into q0, which is take outside the integration because there is no change in this factor but only r is changes, so here means only then we take inside the integration r cap upon r square into dr bar. Then dr bar, but we know that the r cap unit vector of r is 1, means this is the one value. Then here we take the integration only 1 upon 4 pi epsilon 0 q0. Then here integration is r1 to r2, here then these are take numerator, so r raised to minus 2 into dr, r raised to minus 2 into dr. But here we take the we take the integration of r raised to minus 2 into dr. Here we use the integration formula. Then here the integration formula is r raised to n into dr is equal to r n plus 1 upon n plus 1. Here the r value, r raised to minus 2 means n value is minus 2. Substitute minus 2 plus 1 upon minus 2 plus 1, then the value of r raised to minus 1 upon minus 1. Then this is the integration, this is the value of the integration of r raised to minus 2 into dr. Then directly substitute the value in place of r raised to minus 2 into dr. Then the next equation is 1 upon 4 pi epsilon 0 q into q0. Here is the r raised to minus 1 upon minus 1 into r raised to minus 1 upon minus 1, which integration is r2 r1 to r2. Then here r raised to minus 1 means here it can be written as 1 minus 1 upon 4 pi epsilon 0 q0 means 1 upon r, then which is directed r1 to r2, and here is the minus sign. Because of this minus minus get positive, then the next equation of this is 1 upon 4 pi epsilon 0 q0. Then here we substitute the lower limits and upper limits in place of r. First we substitute the upper limits 1 upon r, and if we substitute the lower limits and upper limits, there is a minus sign between them. Then 1 upon r2 minus 1 upon r1. This is the equation of the increase in potential energy. Then increase in potential energy is nothing but the work done. Then the equation of the work done is same as that of the increase in potential energy, means 1 upon 4 pi epsilon 0 q0 in bracket 1 upon r2 minus 1 upon r1. This is the value of work done whenever the charge move from point A to B. Q1 and Q2, which is separated at distance r, then the potential energy between these two charges ur is equal to the 1 upon 4 pi epsilon 0. We know that integration is from r1 to r2, but r1 is infinity and r2 is equal to 1. Then the equation of this is potential energy is 1 upon 4 pi epsilon 0. Two charges is q1 q2, distance is q1 q2, and distance between two is r square. So this is the equation of potential energy when the two charges are separated by a distance r. Here is the SI unit of potential energy. SI unit of potential energy, potential energy is joule. Then another unit of this potential energy is electron volt. Then conversion of this electron volt, 1 electron volt is equal to the 1.6 into 10 raised to minus 19 joule. Then another conversion is 1 mega electron volt is equal to 1.6 into 10 raised to minus 22 joule. And another is 1 kilo electron volt is equal to 1.6 into 10 raised to minus 16 joule. This is the convergence electron volt into joule.